Hi, welcome to the first video for week 1 of the Math 310 lectures. I'm going to give you an example of a new proof technique, which is really not even a technique, but it's a way to start approaching problems when you don't have a plan, which for me is almost all the time. So I call this approach start writing. And like all things in life, math, everything, it's best to just teach by example. So consider the following problem, or the example. In fact, that's really a theorem. The product of two odd integers is odd. Okay, so it's a completely reasonable statement. You've probably seen it before. If you haven't, you're going to learn something today. As a side note, this probably isn't important to you yet, but I promise it will be by the end of the semester. A good way to turn this into a first-order statement is the following. And I'm not going to fit it on one line because of camera constraints. So for all m and for all n in the odd integers, their product, which is m times n, is also in the odd integers. There's other ways to write that, but this one fits on the board. So let's prove this thing. And as I prove it, I'll go through and explain where the proof came from, because it's not magic. Okay, so the first step to virtually any proof, the proof technique is called start writing. So probably I'm just going to start writing aimlessly. So let m and n be odd. Cool, that's a good start. We want to prove something about m times n, so it's good to know what m and n are. The problem guaranteed that they're both odd, so this is not really a stretch. So fine, we don't really know anything yet, but let's try writing out what odd means. Then there are integers a and b where m is 2a plus 1 and n is 2b plus 1. Okay? Reasonable. Again, everything that I've said so far is something that you should pretty much expect that you should have to write. Here we've got a state with the variables r, obviously, and then since we're going to prove something about oddness, probably I need to say what the definition is. It's not always true, but it's often true, and it's usually just a good way to start. If you're not sure what to do, start writing down stuff that you know. And when I'm working and I say odd, the only thing that I know is that I have some integers where m is 2a plus 1 and n is 2b plus 1. And note, there's no significance to the letters a and b. I just didn't want to use k1 and k2. Anyway, so this phase is what I call state the hypothesis. Okay? Because it's just a good place to start. Even, no matter what you're doing, no matter what proof technique you think you're using, this is going to be how you start. And sorry, it's really weird for me to look at the camera because this is a really empty room. Anyway, so let's go. So that's phase 1, or maybe phase 0. And anyway, the rest of it is just called, I just call go for it. And by go for it, I just mean well, the end has to do with m times n. So fine, let's go for it. Let's see what we know about mn. So mn, well, I hope that it's equal to 2k plus 1 for some k. I don't know what k is, whatever. But mn is equal to, well, the only thing I know, the only thing that I can write here is m is 2a plus 1. And n is 2b plus 1. This line was inevitable. There was nothing else I could have written here because I don't know anything else. Someday maybe you will, but for now, what else are you going to do? There's nothing else you could do. So anyway, I've got this stuff, and now I'm looking at this blob of algebra, which is not helpful. And so the only thing that I know how to do is the only thing you know how to do that you've known for a long time. You expand this. You FOIL it. Now, trust my FOIL, if you like, or do it yourself on your own paper. But you get this thing. So you get multiplied out. I got 4ab plus 2a plus 2b plus 1. And what I know I need to do, I need to prove this thing is odd, which means I need it to be 2 times something plus 1. Well, luckily, I've already got a plus 1 just hanging out, so let's just leave this alone. Right? If we're just going to go for it, and we're going to hope that everything works out easily, then let's just hope that the plus 1 is the plus 1. Why wouldn't it be? Now what's cool is that what's left over is something that's divisible by 2. We've got a 4 and a 2 and a 2, so I can pull out a 2. And when I pull out a 2, I'm left with something that is obviously an integer. Okay? And now if you look at what we have, just knowing the fact that m and n were odd, I can just say that mn is this stuff, and then just by purely blind, brute force, whatever, boring algebra, I get it that this is equal to 2 times some integer plus 1. So mn is odd. And that's the end of our proof. Okay, so the thing to notice here, the real technique is you just write. You just have no plan. You don't do any scratch work. You don't do any thinking. You just start writing stuff. And at the end, you want to sort of keep your goal in mind. Where I need 2k times, or I need 2 times something plus 1. And you just sort of notice that it works. So yeah, that's the first most basic proof technique, is just go for it. And that's it. So I would say post questions in the comments, which you can do, but you can also email me or talk to me in person like a human being, because this is not that online of a course. Okay, so hope you got something out of this, and there will be one more video.